Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working on our metal planer restoration, and previously we've been working on the saddle. This is the part that slides on the crosshead. The clapper box amounts to this, and the clapper box is the part that has the cutter in it that actually does the cutting and the work on the machine. Now, before I can put this back on, I need to get all the pieces and stuff installed on this, and I got a little issue with this part right here. That's a T-bolt that fits in here, and there's this T-slot that goes around, and again, that clapper box mounts on this. It can rotate around at whatever angle you need it, and this basically, there's two of these bolts that go through here. Get it lined up the right way. There's a hole in the back that allows you access into that, and once it gets in there, it can slide around that circle. Now, here's the issue. We had two of these on here. One of them was missing when I got it, and it had been replaced with just a square-headed bolt, totally different design than what was on the original. And the other issue that I've got is that this is a really oddball size thread that's giving me some problems. We're gonna have to do some things to get around it. Let me show you exactly what we're dealing with here. This is the T-nut that we've got to make, and it is a little bit unusual in a couple of things. Number one, we got the larger square that fits into the T-slot. It comes up, looks actually goes back to a round behind it. I'm not sure what the purpose of that is, but then you got another square that actually fits in this groove that goes around here. And if you look real close, that's actually radiused on the top and bottom to match the radius that's in there. And I'm not sure. I don't know that that's super critical, but it just needs to go around. No big deal there. Here's the challenge I've got though, and it took me a little while. When I got this, I said, oh, no problem. We'll just go knock one of these things out. I need to make a nut as well. The nut is really more the challenge to me than anything else, because when I started looking at this thread, I said, well, that's 5/8. No, it's bigger than 5/8. Well, it's 11/16. No, it's smaller than 11/16. It's got a 10 thread pitch. That doesn't look like anything on my charts. You got to remember, this machine was built somewhere between 1885 and sometime in the late 1890s. And then according to some research I've seen, by the late 1890s, they had made some fairly significant modifications to the machine, and mine probably falls in that mid 1880s to mid 1890s time frame as to when it was built. During that time period, there were no standards as far as threads and whatever. It's just whatever the manufacturer wanted to make, that's what they made. They kind of use their own internal standards. And the thread on this, you ready? It's 43/64 of an inch diameter. You heard me right. And I'm not making that up. And yes, I have checked it over and over and over again. And I've actually ran into the same thread pitch on some other parts in the planer as well. 43/64, 10 threads per inch. Now, cutting the threads on the lathe is not a problem. I can cut whatever thread I need. The problem I've got is I got to also make one of these nuts, and the nut, I have to put the threads in there. I don't have a way to tap this because I cannot find a 43/64 10 tap short of making one, and it's just not worth the effort. So here's the game plan. The bolt they put in here, that's actually a 5/8 bolt, standard size thread. We're gonna make this, the bottom side down here is gonna be 43/64 so that it will fit up and register inside of that clapper box, but it goes around. The threads, though, I'm going to turn down to 5/8 11, and it's just a compromise I'm going to have to make in this particular case. It's just going to be way too expensive in both time and or money to either make or have made a tap just for two nuts. I'm just not going to do that. So that's what we're going to do is we're going to remake this part. I'm going to make two of them, and again, this will be 43/64, but the threads are going to be 5/8 11, a little bit smaller, but the bolt goes down on there. As long as it tightens up on this neck down in the bottom, that's all that matters. So there you go. Let's get over to the lathe and get started. I've got a piece of 1¼ inch square stock, which is the same square diameter, or not diameter, but dimensions as the original nut. That's what we're going to be working with. Let's get over on the lathe and knock a couple of these out. I'm over on the Monarch lathe, 16-inch Monarch lathe, and I went and pulled my chuck out here, my 4-jaw chuck. But this is a special 4-jaw chuck. I have used it in many videos. I actually bought this chuck some time back when I was doing a lot of square head bolts I was having to make on a restoration that I was working on. And while normally with a 4-jaw chuck, a typical 4-jaw chuck that's used in machine shop, each jaw is independent. So you can move it in and out, and you can use it to fine adjust and get something running exactly true. Very handy tool. I use my regular 4-jaw chuck all the time. 3-jaw chucks, when you adjust those, there's a scroll inside of this, and all of the jaws move in and out together. The downside to a 3-jaw chuck, as you probably know, is that typically you're going to have some small amount of run out. So if you're doing something real precision where you're having to put something in and get it running exactly true to the part, a lot of times we'll use a 4-jaw chuck to do it. This chuck is unusual in that it is a scroll chuck. When you move it, all the jaws move in and out together. So this is like a 3-jaw chuck, it just has 4 jaws. So the nice thing about this is when you're doing something like bolts, I don't have to go around here and move each jaw around and indicate it in to get my part to run true. Is this running perfectly true? Probably not, but it's running close enough on this particular part. It's not going to matter because it's not critical that the square part back here be perfectly concentric to what we're turning. It's going to be within a couple of thou because this chuck is a fairly accurate chuck. So anyway, I just thought I'd show that. This is a different style 4-jaw chuck. You don't see these very often, but they're available. You can pick them up, and I use mine all the time for doing exactly this, gripping square stock. We'll start by marking on here. So we need to cut this out. I'm going to need to turn back to basically this first square. So we'll go this way. I'll just mark that on here with a Sharpie pen. This will give me an indication as to how deep I need to turn that, and we'll get started on this. I think we'll actually start the turning by facing the end, putting a center in here. This is as far back in I can get this piece to go. As the measurement across the corners here is a little bit larger than my through hole, so I can't get it to go back any farther. And because of that stick out, I think I want a little bit extra support on the end, so we'll put a center in this. So we are going to start again by facing this. I'm going to come in here with a center drill and put a center in here. And this center will give us that support we need out there on the end. Now we can start turning, so I'll come in here and touch off. And let's roll across there. I'm just cutting the corners right now. I'm taking a pretty good hefty cut on it. Go right up to that line that I marked in there. And I think I am going to speed up my feed rate a little bit. That's going a little bit slow there. Just want to check the finish. Yeah, that's turning out really nice. So we're going to continue on. This has got to go down to 43/64, which is 0.671875. We got a ways to go. We're a little over an inch right now. Bring you back in a minute. We're getting down kind of close here. Let's get a measurement, see where we're at. And looks like we're at about 780 thou. We need to be at 671, so we got just a little over 100 thou to go. So I'm just going to dial in 100. And then we'll take a final pass to clean it up. All right, we're at 681. We need to be at 671. So we need to take another 10 thou off, and we should be right on the money. Just a light pass to clean it up. I'm gonna come back here and face this back shoulder here. I want to leave the 43/64 diameter up to 1 inch on that, and then we're going to turn this down to 5/8 and thread that to 5/8 11. So I just got a mark there at my 1 inch mark. A little bit better mark to see there. So we're at 681 or 671. We need to go to 625. So we got a little less than 50 thou to come off of it. I'm going to touch off. We'll do 40 thou, and then I'll clean up the rest. And I got, looks like I need to pull about 9 thou off. And 625, we're right where we need to be. I'm going to use my threading tool to put a nice big leading chamfer up on the front of that. So I need to set up for 11 threads per inch. This is my quick change gearbox here. I see 11 right here. So I need to first move my tumbler over to that row right there. And then I need to look on here and see for that line, I need to have my levers on AE. So we'll switch this up to A, switch this one down to E. Let me turn my chuck. There we go. It has to be all synced up with the gears. So we should be on 11 threads per inch, and I need to move this over. That goes from my, this switches the gears from the feed rod to the lead screw for threading. So we should be set up now for threading, and we'll verify that 11 threads per inch over on the cut. All right, I'm gonna come in here, feed in till we barely touch. Just want to scratch. There we go. And I'm gonna thread across there, and we will check our thread pitch. And we are on 11 threads per inch. That's good. So let's cut these threads. check this for fit. Typically I'll start turning until we get kind of to a sharp point at the top, and that kind of indicates that we're approaching the thread max or depth of cut, and I'm close right now. I think I'm gonna have to take a little bit more, but let me grab a nut and check it. And as I suspected, it's a little bit tight. I'll take about another 5 thou off of it, and we'll check it again. All right, let's check that. A little bit more. All right, that's screwing up on there nice. So that's going to be our final depth of cut. So if you look on the original here, we've got, kind of goes down to a parted circle in the bottom there between this big square and the little square. So I'm just going to use my parting tool. I got a line marked on there where I want to go in, and we're just going to take it down to roughly that diameter that's in there. I got a line on there that I'm just kind of lining my parting tool up on. And we'll just slowly feed in there. I can kind of see the diameter of the bolt. This diameter is not critical by any means. I'm just kind of eyeballing it, give them about the same, and that groove is actually thicker than that, so I'm going to make another pass in there and widen it out just a little bit. Again, I don't think anything, these measurements are critical by any stretch of the imagination. And that's roughly the same size slot in there. And the final step here is we will part this piece off. It needs to be about 450 thou thick. I'm just going to put a mark on here. I think I'll cut it a little bit on the thick side, then we'll turn it around and face it later. I want to take my center off here because we are going to be parting that completely off. I'm just going to give me a little bit extra thickness there. All right, parter. And there we go, that's our roughed out bolt. I'm gonna go ahead and make another one, then we'll turn these around and face this side off to the right thickness, and then we'll have to go over to the milling machine and cut this square here down to the proper dimension. So guys, I've got the part now in a square collet block. This is gonna allow me to mill that smaller square behind the head here and do it right. I need to get this down basically to that same diameter as that shaft back there, which means we got to take a good bit of material off of this. I've already touched off here and zeroed that out, so I think I'm gonna do about 100 thousandths cut per pass to try to get through this as quick as I can. And we'll just come across there. I don't want to hit the back side there. All right. And I'm just going to rotate this around With it being in that square collet block, this will help me keep this thing square. So we'll rotate it 90 degrees and do the same thing. All right, so I'm taking that off. I'll do this. Do this. Be there. Ready? 30. 71. All right, let's see what we got here. I did kind of go over and just take a file and knock the corners off of one side of that little square that comes up in here to kind of match that radius. And we've got a hole in the back that just fits right up into. It rotates around. Make sure I get this one in the right way. Same thing here. Come in there. We have our now T-bolts ready to go. Last thing I need to do is I need to make a couple of nuts. Obviously this one here is for, what was it, 43 64 10 threads. I need some with 5/8 11. I've got some hex stock. We'll make these, just drill and tap them out real quick, and I think we'll be done with this project. I've got some hex material that's the same size as the originals here, and we're gonna make a couple of nuts. I'm gonna start by just getting these cut to length, and then go ahead and do the machining on the ends and all that, and then I will take it and drill and tap them in a separate operation. I just don't want to have to drill and tap into a blind hole. I'd rather have it cut to length and drill and tap through a through hole. Less likely to break a tap that way. So start by facing the end here. Got a lot of stick out here. This is as far as I can get it to go. It won't fit up through the spindle on my chuck, or the lathe itself, I guess, but that's all right. I'm putting a threading tool in here to put the chamfer on there. If you look on the original, you see that chamfer that's around, and that is the same angle that's on the threading tool, so it's going to work out just fine to use that to chamfer it with. And we'll just kind of come in here and put that right on there. Yep. And then we'll put our parting tool on and part that off. Use the original as a guide here to get my length where I want it. The length is not very critical. And we'll just part this joker right off. I'm going to lightly face the bottom of this just to give me a nice clean surface. Using a center drill here just to give me a little dimple there in the middle. Get a hole started. Got a 17/32 drill bit here. This is for a 5/8 11 tap size. We'll just go ahead and drill all the way through. Gonna countersink that a little bit. Help get my tap started. Slowed everything down. And I'm gonna put some cutting oil up inside of here. I've got a 5/8 tap in here. Notice I got it on the tailstock, and I don't have the tailstock tight. It's just sliding. I'm going to let it just pull itself in. When we get to the bottom, we'll stop it, reverse the lathe, and we'll let it pull out. I'm not trying to feed this in. We're just letting it pull in by itself. So let's just get this tap going. We'll just start it and let it just feed right on in. And I've got a little spinning going on. Let me see if I can get this a little bit tighter in my chuck. I am going to reverse that out just a little bit. Now let's continue on. Maybe this will go on through. There it goes. We'll just let that tap come out the bottom and then reverse it to come out. And I think that this project is coming to an end. Looks like we've about got everything done here. So our T-bolts fit in nicely. Our nuts fit on here nicely. And with that, I think we're going to call this project done. And with that, I think I'm also ready to look at putting the saddle back on the machine. And with that, guys, that's going to be a wrap. As always, thanks for hanging in there with us and watching this project through completion. Please subscribe to the channel if you haven't already, and a thumbs up are appreciated, as are comments. And we will catch you on the next video. Thanks for watching.